So today we're going to talk about dark web. To start, fentanyl has killed more than 100,000 Americans. Ransomware has devastated US companies, costing billions of dollars in property damage, intellectual damage. Not only companies, but private institutions and government agencies. And Russia, as we all know, has invaded Ukraine, killing tens, if not hundreds of thousands, displacing millions, and provoking a strong response from the United States and NATO. You might ask, what do these things have in common? One, they are national priorities with urgent intelligence needs. And two, they are all on the dark web. My name is Jason Nack. I am the head of technology for a company called Bluestone Analytics. We are a CACI company, or CACI in the vernacular. And we allow you to access, attribute, and analyze hard-to-get data from digital environments, such as the dark web. We've been Elastic users and customers for years. Primarily, our platform is built around the search technology and capability. But because we have our own product and infrastructure, we're growing users of observability as well. And these search capabilities, primarily, I'm going to mention a couple times, are critical to powering national security and law enforcement missions of our customers. So what is the dark web? Drugs, hackers, yes, but also many other things. Counterterrorism, human trafficking, ransomware, as I talked about. It's also used for bypassing censorship in authoritarian regimes. It's used for free speech and distribution of news, including on-the-ground reporting. I've mentioned fentanyl. This is a major problem in the United States. It's now the leading cause of death among young people, all types of death, specifically overdoses. People overdose from fentanyl, and it's readily available on the dark web, both in its true name, sold directly as fentanyl, also sold under street names or laced with products that don't specifically mention fentanyl, but end up being laced with it and causing overdose deaths. So it's a big problem. It's sold under anonymous personas because the dark web is anonymous and it's hard to get to. It's also, as I said, not always readily apparent that fentanyl is being distributed from these dark web environments. One thing we see is users and purchasers of products who leave reviews to warn other users if a product is laced with fentanyl so that they can beware. Ransomware, really big on the dark web. It's a place where ransomware groups organize and communicate. Many of them have public-facing websites, so they announce their exploits. They also use these websites to share files and data that they've stolen. So a ransomware group might break into a company, they steal all the sensitive data, then they encrypt it all so the company can't recover it. And if it's known as almost a double ransom, so you pay to decrypt your files, you also pay for the privilege of not having those files released to everybody in the world. Sometimes groups will release that data for free. Sometimes they sell it to the highest bidder. Ransomware groups also use private websites, so it's a typical means of communicating with victims. Hopefully no one here has experienced that, but you might get a ransom note saying, go download the Tor browser, go to this onion address, and chat with us about the price we'll set for your data. Interesting and newer use case that's sort of not expected is used for grassroots organization, essentially crowdsourced unconventional warfare. So with Russian occupation of the Ukraine, there are Ukrainian groups who are using the dark web to collaborate on guerrilla warfare. They share guides, techniques, they share targeting packages, and then they share, as you can see, pictures of their exploits. You can imagine how powerful this is. This allows distributors of content to anonymously share this information and the consumers of content to access it anonymously as well. So the people conducting operations have no physical connection to the people organizing them. So how do we help, and where do we come in, and how does Elastic underlie all of this? Our Dark Blue intelligence platform allows us to collect and organize all of this anonymous and hard-to-get data. We put it into a large Elasticsearch cluster, and then we make that data available for search to our customers. Search, search, search. You'll hear this a lot. It really is at the core of Elastic, and it's critical to our customers' missions. We take all of our data, past, present, we're constantly growing. We collect in multiple languages, more than 60 at this point, and using the search capabilities innate to Elastic, users can sift through all of the noise, all of the anonymous personas, all of the hard-to-reach places, and find their data of interest, whether that's a drug vendor, whether that's an information operation, whether they're looking for sentiment in a target language. All of that's available at their fingertips because of search. Boolean operators, right? Fuzzy matching. So if you know a person's vendor name, say that they're using in a marketplace, and you want to see all the variations of that across all markets, dark web markets, you can do that easily. And then filtering and pivoting. So the way we've structured our data, we enable you to do full text search, which is the great thing about Elastic. But Elastic also has these great keyword fields, right, in your data structures that allow you to filter for an exact match of a value. So let's say you've searched for a term like fentanyl and maybe heroin, and you get way more than you would expect back. Now you find someone of interest selling these products, and they have an email address that you find. Well, now you want to find all of the places where that email address has been used. Filtering is your key. You can filter on that address and find all of the other personas that that person uses, all of the other products that they're selling. It essentially allows you to turn a breadcrumb, your starting point, a single piece of data, into a full-fledged investigation. And archiving. All of this data is meaningless if you can't store it. And Elastic makes storing lots and lots of data really easy. We have no retention period. So unlike many of the logging use cases where you might hold data in a hot storage for a couple weeks and then roll it off to cold and then eventually maybe delete the data altogether, everything that we collect, we hold forever because it's always relevant to some mission. For many of you, maybe this is the first time you've heard about or are thinking about the dark web, and you might realize it's relevant to your mission and get interested. And you might be sad that you don't already have this data, but have no fear because we're the archive for that. So you can hop on today, and not only do we have real-time, constantly streaming ingest of new records, we also have data going back 20-some years across historical sources. You can see some of the metrics about documents and the number of sources we have. Each source that we go to has a different data structure, a different data format, different languages I mentioned. Elastic makes it easy to take all this disparate, unstructured data and turn it into semi-structured and fully structured forms. We make heavy use of templates and some other things I'll talk about. But I can't emphasize enough how much Elastic has helped us in organizing these really disparate data sources and making them standardized and searchable in an easy way. Okay, so looking at the tech underneath, we use a lot of features that Elastic provides, and hopefully some of these you're familiar with, maybe some of them are new to you. On the indexing side, I mentioned templates. So templates are really great ways to create a consistent structure for your data, especially across certain index naming conventions. So this allows us to make sure we have a standardized schema, a set of fields that all of our data conforms to as we ingest it. We can set it up once, indices roll over, new indices are made, and we don't have to restructure our data each time. Paired with that is the flexibility to constantly add new fields, right, unstructured. Because we come across a new data source, it has data we haven't seen before, we want to add that in. The flexibility of Elastic is really great. Index lifecycle management is awesome. We roll over a lot of indices, or indexes, constantly. We're constantly filling up our data stores, and we roll those over to keep them performant. And that only works if you can use aliases. Hopefully, everybody is, but aliases help us a lot, including filters. So we have aliases where we filter out certain types of records and documents, but they're also great for hiding the underlying index data structures, right? So we can present a simple, standardized interface to customers and to ourselves while totally transforming the underlying data structures. One of our data folks is here today, and I think he's done 5 total refactors of our data underneath one of our aliases in the last 2 weeks. That's like 1.4 terabytes of data that we've totally reconfigured a couple times and moved around, all with no external facing impact because that alias presents a standard naming convention. On the processing side, we use language detection models. These are built into Elastic. They're available in the pipeline processors. We use that to detect those 60+ languages we come across and then store them in data fields with specific language analyzers. So Chinese, Japanese, Korean, Cyrillic. It allows better and improved search in those native languages. We use stop words and other analyzers. There are some great analyzers for URLs, for email addresses, things like that. We deal with a lot of web-based content. So obviously, if you search div, you don't want to find all of the div tags necessarily in a HTML site. And then enrich processors. These are great ways to take a subset of our data, use it to enrich new data as it comes in. This is an automatic process. It happens at ingest, and it makes our data as robust and as valuable as possible. Because we have our own product and really suite of products and a large amount of underlying cloud infrastructure running all of this work, observability has been really great. We've been rolling this out recently. We have a lot to learn, but some of the things we've started implementing and benefiting from. Fleet and agents. These are really great, easy to deploy, and instantly data starts coming back and showing us where things are running, how they're performing. AWS Fargate, there's an integration for that we've made use of. It gives us easy insight into our hundreds of containers in AWS. So if there's an outage, an incident, if things are slowing down, we can easily identify where that is and why. And then APM. This is great. We run this on our API. We've also made use of real user monitoring. So we have a web-based application. Real user monitoring lets us see what are users experiencing, right? Is our application slower on Firefox than it is on Chrome? Is a certain search request longer and slower than another one? It's really great. It's powerful. Like I said, we're just getting our feet wet with this, but I highly recommend you check it out. And then on the hosting side, we're self-hosted. So we use AWS. We run our own EC2 instances and servers. We install and manage Elastic on top of that. So we have familiarity with everything from YAML files to indexing strategies. We have 3 environments: development, production, and observability for monitoring everything. And we're currently on Elastic 8.x, I believe 8.6, but our team is really familiar with rolling restarts, for those of you who have been through that. And we've come a long way. 4 years ago, when I started, the other engineer and I at the time would plan out for 2 weeks how to do an upgrade, and we'd spend an entire night doing it off hours. And now our infrastructure team rolls it out during the day with no impact, and we're good to go. So I talked about our API. As we grew in our use of Elastic and started exposing our data and providing it to customers, we realized we needed to extend some of the capabilities available in our data source. So we built our own middleware on top of that allows us to integrate with third-party identity providers, some other data sources. It becomes a common plane for our internal tools and services. And we also added GraphQL, which is really great. It's a really convenient software layer that allows you to turn your Elastic data into a graph database, essentially. Allows you to write graph queries, get graph responses back. So a common case for us, again, is you might do a search for, let's go back to fentanyl and say, show me everything you have on fentanyl. And then you might find some of those records have Bitcoin addresses in them. And then you want to see, show me all the places that Bitcoin address has been. And then show me all the products those people are selling. That's a graph query and a response that is really easy with GraphQL plus Elastic. So last thing I'll show here is kind of the data pipeline end to end, right? From the raw environment all the way into Elastic and where they play in there. So we do the hard work of accessing these environments, going out, getting into marketplaces, into forums, grabbing the raw data. Then we pull that in and we do some data structuring, engineering, formatting, parsing. We do categorization, we run AI models. And after all that, we import that into Elasticsearch, and we run some additional processors that I've talked about. Bulk imports are really great. They allow us to do batch imports and import at scale. Our volume and our daily and per minute, per second volume has grown constantly over the last few years, and Elastic has had no problem scaling to meet that need. A couple other things we do that might be unique. We do a lot of scrolling queries. So we query our own data as for targeting information, and we scroll through that on a regular basis. We also we access the same environments repeatedly, right? We're in some places every 4 hours, every day. And one thing we want to avoid is creating a lot of noise in duplicate data. So to avoid this, what we've done is created our own ID value. So we have a deterministic hash that we create out of our data, and we use that to overwrite the automated Elastic ID. Those of you that are familiar with this. So Elastic, by default, automates, it creates a UUID, and it's great. It's unique to an index. We need to know that the record we're ingesting is unique across all data sets, and if it isn't, or if there's an update to some of the content, we want to update that value. So overwriting the ID value with our deterministic hash, one, gave us a larger number of possible unique values, but it also allows us to handle our data governance in a way that we need. And you might ask why overwrite the ID rather than just create a new field? The main reason is a really nuanced performance thing, which is that ID lookups are faster than term filters or something else. And it also allows us to automate the process of ingesting the same record at that ID. If it's the same, nothing happens. If it's updated and new, it overwrites. So maybe that's a cool tip for someone. All right. Hopefully you've taken away that these digital environments are operational. They contain data relevant to national security and law enforcement missions. The incredible engineers, who I can't compliment enough, they do the hard work of making search and storage and indexing and rollovers and ML pipelines. They do the hard work of making that readily available and easy to use for us. So we can do the hard work of going out into hard access environments, grabbing data, making it available to you, so that you as analysts and agents and people in the public sector can do your hard work that keeps us all safe. So thank you. If you have other questions, either on Dark Blue, our product, or how we use Elastic, feel free to find me, ask questions. I'll be around and probably over at one of the booths. This is my contact information, and you can do the QR code if you're interested in a trial, if you want to go see for yourself what's out there. Thank you.